So in today's lesson, we're going to be converting first from vertex form to standard form. And then after we do that, we're going to go backwards from standard form back to vertex form. So remember that vertex form is y equals a times x minus h squared and then plus k. And we want to basically get rid of our parentheses and get rid of our squared and turn that into y equals ax squared plus bx plus c. So we're going to copy this down into our notes. And step 1 is going to be to FOIL the x minus h squared part. Now I want you, on this part it's important, we want to leave an a and then a big parentheses. Right, so we're just foiling that part, but the a still needs to distribute to everything. Then step 2 will be to distribute the a. And then finally, step 3 will just be to combine our like terms. So we'll do an example here. Let's start off with one like this. So step 1, we said, was to FOIL just this part. So when I write this, I'm going to still write my a, my 2, but then I'm going to change x minus 2 to look something like this. Parentheses x minus 2, parentheses x minus 2. Notice that I put a big parentheses. That way I can make sure to distribute the 2. So we're going to FOIL this out. X squared minus 2x plus 4. Right, if we're doing PEMDAS, we're going to do everything inside the parentheses first. And we definitely could have just jumped from this step straight to this step if we remember the shortcut. Right, and so that shortcut would have been that, when I have the x minus 2 squared part, that I square this first term, which is here. Then I multiply them together and double it. And then I square this second part. So if you remember the shortcut, you can definitely do that and just go straight to that third line. And now I'm going to take step 2 up here, was to distribute the a. So I'm going to take my a term and distribute that. And this is very important. Don't forget the minus 3 at the end. That's what I see a lot of students do, is they distribute it, but they forget that minus 3. Don't forget that part. And now we're going to, step 3 was to add our like terms. So hopefully that's easy enough. We can do one more example, and this time I'll do it with that shortcut. So let's do y equals negative, parentheses, x minus 3 squared plus 2. So first step I'm going to do is to leave that a, which in this case is the negative sign, but then put a parentheses and FOIL this out. I'm going to use the shortcut. So I square the first one, x squared, multiply x times negative 3 is negative 3x, double negative 3x is negative 6x, And then negative 3 squared is positive 9. Then I'm going to take my a and distribute it. And make sure we leave that plus 2 at the end. And then now I'll just add my like terms. We have y equals negative x squared plus 6x minus 7. Right, and it's important to remember that if I graph both of these, they're the exact same graph, right? These are the same. It's just that they're written in a different form. But if I graph them, I would get the exact same graph. So that's going from vertex form to standard form. Next up, we're going to do standard to vertex. And this one is a little bit trickier. So basically, we want to, on this one, factor. But if you look at it, it's not all factored, and it's a perfect square factor. Right? And that a is still outside. So, here, step 1 is going to be to factor out our a. And then step 2 is going to be to complete the square, which is a little bit tricky, and we may have forgotten how to do that. And so we'll kind of talk about that process as we go. Now, this is a little bit tricky because we're just going to complete the square with, basically the x squared, the ax squared plus bx part. So we'll do some examples and we'll see this. It is a little tricky for sure. And I think doing examples on this will kind of be the best way to solve it. So this time we're going to convert back to vertex form. So first one I'm going to give us will be easy because there's no a term. So x squared minus 8x plus 15. So step 1 is already done. The a is already factored out. So if a is 1, we don't have to worry about step 1, which is easy. So we just need to worry about completing the square. But again, we're only going to complete the square for this part right here. We're going to leave the other part alone. So what I like to kind of do to start this off is I like to put a parentheses around that part. So I'm going to put x squared minus 8x and then plus 15. Right? And actually, this kind of reminds me, when I do the factoring, I just factor out the a from the ax squared plus b part. Right? This c is always going to stay outside. And the reason the c is always going to stay outside is, let's look at the equation for vertex form. We have a plus k outside. So we don't want to factor the just number. Right? The number 15 is going to stay outside. It's not going to be the k. The k is going to change, but it's going to be in that spot, in that location. Okay, so to complete the square, remember what happened was we have, basically some like x minus h squared, right? X minus some number squared. And when we perfect square that, when we FOIL it out, we get, x squared. Then we double those, so it'd be minus 2xh, and then plus h squared. This 8x is in this 2xh spot. So to kind of get rid of it, we're going to ignore the x. We're going to divide by x. But then we have to take that number 8 and we have to divide it by 2. So whenever you're completing the square, this is kind of a reminder. You can put this off on the side. Is we're going to take b divided by 2. Right? We want to find this number. So we take b divided by 2, and then we square that number. And that's how you complete the square. So I'm going to take 8, right? And, negative 8 really, divided by 2. And then I want to square that. That's negative 4 squared, which is 16. So what that means is, in order to get a perfect square, I would have had to have plus 16. Well, I don't have plus 16. So what I need to do is I need to come in here, and inside my parentheses, I'm going to just add a plus 16. But in math, I can't ever add plus 16. That's going to change my whole graph. Right? That would shift my graph up by 16 if I added on 16. So what I have to do outside the parentheses is then I have to subtract by 16. Right? So if I added 16 and I subtract 16, I didn't really change anything. I just, basically added 0, which wouldn't change my graph. But because I have this parentheses, now what I can do is right here I can think, what are two numbers that add up to 16? Sorry, multiply to 16 and add up to -8. And that's -4 and -4. And if you notice, though, that pattern is always going to be this guy up here, which is, what we wanted, right? Let's use a better color. So right, that is going to be the same as this, and that's because what we did is we intentionally found the number that would perfectly complete the square. So this now becomes x minus 4 and x minus 4, or simply x minus 4 squared. Then plus 15 and minus 16 is -1. And so this would be our vertex form. Right? I know it's a little tricky, but if we kind of go back, let's look at what we did one more time. So we started off and we had, we basically just separated this ax squared plus bx part. So I put a parentheses there. I took my number b and I divided it by 2. Then I squared that, and I add this number inside the parentheses, and I subtract it outside the parentheses. And from there, I just take this and I factor it. It's always going to be a perfect square. And this number, when I did b over 2, that number is always going to be the number that factors. And then on the outside, I just combine my like terms. We can do one more, and then we'll jump into the couple hard cases. So let's do y equals x squared plus 6x minus 4. So step 1 is going to be to put that parentheses around here. And then I'm going to take this b term, 6, and I'm going to divide it by 2, and then we'll square that. So that's 3 squared, which is 9. That means inside my parentheses, I want to add 9. Outside my parentheses, I'm going to subtract 9. -4 and -9. And then this becomes, if I factor it, two numbers that multiply to 9 add up to 6 are 3 and 3. Or I just simply look up here for that 3. So x plus 3 squared. And then -4 and -9 become -13. And once you get the hang of that, it's not too hard. The hard part is going to be when we have an a number that's different than 1. So one like this, where we have this a as 2, is just a little bit trickier. There are a couple extra things we need to remember. And they're just, kind of about math, but the process is the same. So we're still going to kind of isolate this part and leave the +9 on its own. But what we need to do is we need to factor out the 2 from that part. So we can't have that 2 in front, because remember, when we look at what we're trying to get to vertex form. And if you look, the a, the number, is out here. In front of the x is just a 1 is in front of the x. So this is that step 1 when I was writing up here our steps, is to factor out the a just from the ax squared plus bx part. So what could I factor out from that part is a 2. This is kind of similar to factoring by grouping in a way where we're only factoring the 2 from that first part. So that gives me x squared minus 4x. Then close my parentheses and the +9 is outside. We didn't factor out a 2 from the +9 part, just from the first part. And now it's similar to what we did with completing the square, but that 2 is going to get in our way. It's going to be a little tricky and we're going to have to think about it. So we're going to start off the same way. We're going to take that -4 and we're going to divide it by 2, and then we're going to square that whole thing. Right? And I always like to divide first and write that out, because when I do that, that number is going to be the number that goes into my 2 factors, right? Like the h. That number, this number is always going to be the h number. -2 squared is +4. which means I need to add 4 inside and I need to subtract 4 outside. But it's going to be a little bit mean because of the 2. So what I'm going to do is, really, I'm not adding 4 inside, but I'm adding 2 times 4, which means I really added 8, right? Because when you distribute 2 times 4, you added 8. But inside, I put a 4, right? That's the number that needs to go inside. But really, what did I add? I added 8, which means, remember, I add the same number and I subtract the number. I need to subtract by 8, not by 4. So again, I'm going to I know this might be confusing for some of you. So let's look up here and see how, we did 6 divided by 2. We got 3. 3 squared was 9. We added 9. We subtracted 9. Why did we need to subtract 9? Because we can't change this. So if I add 9 to my equation, I also need to subtract 9 so that my graph remains the same graph. I don't move it at all, right? In total, I need to have added 0. But I just add 9 inside so I can factor it, and outside to keep it as 0. Here I add the 4 inside, and instead of subtracting by 4 outside, I need to do 2 times 4. Because if you think about this, if I distribute this, what do I really have? 2x squared minus 8x plus 8 plus 9 minus 8. The 8's cancel. And this is exactly what I started with. So by subtracting 8, I make sure that I didn't change my equation at all. Okay, we're not going to do any of that, but I'm just trying to show you why we subtract 8. Okay? So what were the things that I did so far? I factored out a 2. And then I took this b term, negative 4 divided by 2. I squared it. I got 4. So I added 4 inside. But then I subtracted 2 times 4. I subtracted 8 outside. Okay, now we're going to factor this. And we're going to leave the 2 right there. And my 2 terms are going to be, like I said, the negative 2 and the negative 2. So that's x minus 2 squared. And plus 9 and minus 8 will be plus 1. And this is now in vertex form. We'll do one more like this with a different number. And let's do one that's a little bit tricky in a way. Let's do y equals negative x squared plus 5x minus 2. So again, the first step is just to worry about these two and to factor out the a. Now there is an a here. It looks like it's 1, but it's not 1. It's negative 1. So I just need to factor out that negative sign. And that gives me x squared minus 5x. And then close the parentheses minus 2. I don't factor out the negative 1 from the minus 2. I leave that alone. Then I'm going to take that negative 5 term, divide it by 2, and square it. And this one's a little bit tricky because this one has a fraction in it, but that's okay. So negative 5 over 2 squared is just going to be positive 25 over 4. I square both the top and I square the bottom. Okay, so I square the top and I square the bottom. And I get 25 over 4. So that means I need to add 25 over 4 and subtract 25 over 4. But again, we have to worry about that negative sign. It's going to kind of change it. So inside, right, this is what I add inside. So x squared minus 5x, and then plus 25 over 4. Now, outside, I need to subtract 25 over 4 times the negative sign. And this is where it gets a little tricky, but if I subtracted negative 25 over 4, that's as if I added 25 over 4. So it kind of looks like I added it in both places, but this one is negative, so they would cancel. So it's the same process as what I did, but just be careful when you have a negative sign, right? That means I'm subtracting negative 25 over 4 because I have to distribute, just like how we did this one, right? What did I subtract here? I subtracted 2 times 4 was 8. Here I subtract negative 25 over 4 because I distribute. And then to factor this, it's kind of weird to think like, oh, two numbers that multiply to 25 over 4. But remember, this is always my h. So negative, parentheses, x minus 5/2 squared. And then this one is a little tricky. We are going to just have to add fractions. So we are going to have to get a common denominator, times 4 times 4. And that's minus 8/4 plus 25/4. Okay, 1 is negative, 1 is positive, which means I'm subtracting. 25 minus 8 is 17/4. This is positive, so we're going to keep it as positive. So our final answer is going to be y equals negative, parentheses, x minus 5/2, close the parentheses squared, plus 17/4. So this one was definitely the trickiest, partially because of the negative sign, but partially just because we had this fraction. And so it made it a little bit trickier, but the steps are all the same for completing the square. We're going to factor out the a term from our first two parts. So I get negative parentheses x squared minus 5x. We're going to take this number with the x, the b term, and we're going to divide it by 2 and then square it. That number when I divide by 2 is the h. Then I'm going to add this inside, so plus 25/4. Then I'm going to subtract outside, but I need to make sure to multiply by the a first. So I had minus negative 25/4, which turned positive. Then here inside, this was my h, so I do x minus that h squared. And then out here, I just add my like terms. And this one I had to use fractions, so I had to get a common denominator and then add up the numerators. So that's our process. Hopefully that helps out and you can complete this worksheet. If you need to go back and look at any examples, you can. But pretty much everything on your worksheet should match up with one of the examples that we did today in class.